All right, this is the last video, understanding current lab. We've been measuring current in this circuit at different positions and noticing that the current is the same no matter where you place the ammeter. And if we look at our lab sheet now, we're on to step 10. So what we have to do is change the voltage of the bulb from 9 volts to 12 volts by changing the resistance in the light bulb. So let me show you how to do that. So what you want to do is right-click on the bulb and then click change resistance. Left click, click change resistance. All right, so we want to change that to 35, so we just double click there. So 10 ohms is highlighted. Now you want to type in on your computer 35 and then click done. And what you want to notice is when you click done, look at the light bulb. What do you see that's happening? Look at the flow of electrons. What do you see that happens? So let's click done and pay attention to that. Done, and you notice that the brightness of the bulb is reduced and the flow of electrons is slowed down, and we actually go to 0.26 amps on our ammeter, whereas before it was 0.9. So it says which bulb is brightest when connected to a 9-volt battery? Well, obviously, if you look at the simulation here, the 9-volt battery was much brighter than our 12-volt battery. And the question in the labs asks you why. Well, what you want to think about is how much energy from the battery is required to light up a 9-volt battery completely. So remember, energy from the battery in the form of energized electrons is coming out, if you follow the arrow here, and then passing through the light bulb. The light bulb uses the energy for those electrons, all right, in order to light up. So if this needs 9 volts of power / energy in order to light up, then this battery has to provide it. So 9 volts here gets used completely by a 9-volt battery. Or we could say that a 9-volt light bulb requires 9 volts of battery power or energy in order to light up completely. Now in this circuit, we actually have a 12-volt battery. Sorry, we have a 12-volt light bulb, and we have a battery that's only providing 9 volts of energy / power. Okay, so this light bulb is not getting the maximum amount of energy it can from the light bulb in order to light up. This light bulb requires 12 volts of energy / power in order to light up as bright as it can be, but the battery is providing less than that. Okay, so if we want this bulb to light up as bright as it could be compared to the 9-volt one, then we'd have to change the voltage of the battery. Now I know this is not part of the lab, but let's do this. Change the voltage of the battery to 12 volts. We're going to click done in a second. Just watch what happens to the speed of the electrons and the brightness of the bulb. We click done, and you'll notice that the bulb got a little bit brighter and the current actually went up. Okay, not as bright as it could be, but it did get brighter, and the electron flow did go up a little bit if you base it on the amps. If I just exaggerate it and change the voltage now to, let's say, 16, and click done, now we get electron flow even more, the bulb's getting even brighter. So the higher the voltage here, the more energy is being provided to the light bulb, and it's going to glow brighter. Okay, larger voltage light bulbs require a larger voltage battery to provide enough energy in order for the light bulb to light up completely. Now you have, in step 11 here, you have to draw a circuit diagram using the proper symbols. You're going to have to refer to your note. In order to do that, basically take what you see here and draw a circuit diagram for it in the space that's provided for you on your handout. Okay?